In this lesson, we're going to look at the reaction between the halogens and alkanes. Now, these reactions often go under the rather complex name of free radical substitution reactions. Okay, and they're sometimes known as free radical chain reactions, okay, because they involve a chain of processes. Okay, so what we're going to do as an example would take the reaction between methane and bromine. And so in order for this reaction to take place, we need to go through what we call the initiation process, and that requires that the bromine molecule be broken in order for the reaction to take place. So this is done using ultraviolet light, and pretty much the same things that we mention here also applies to the reaction between chlorine and methane. Okay, so we're going to break this covalent bond using ultraviolet light, and that gives us our initiation step. So let's just make a note of that. This is the initiation. We remember that the bromine atom has 7 outer electrons, 3 paired and 1 unpaired, and that shares its unpaired electron with the unpaired electron of another bromine atom. So these two shared electrons here form this covalent bond. And when the UV light interacts with this bond, it splits the bromine molecule into 2 bromine atoms with an unpaired electron. And these are called free radicals. Now, these are not happy in this state, so they don't like having 7 outer electrons. They want 8 outer electrons, so they're going to do something about it. And the first thing it's going to do is going to come over to this methane molecule, and it's going to rob the methane molecule of one of its hydrogen atoms to form hydrogen bromide. So whereas this is called the initiation step, the next steps are called the propagation steps. So our bromine free radical is going to attack the methane molecule. It's going to grab hold of this hydrogen and form hydrogen bromide. Okay, so this electron is going to pair up with the electron from the hydrogen atom here, and that's going to leave a methyl group with a single unpaired electron. This now is a free radical. This is called the methyl free radical, and it's not happy. It doesn't want this unpaired electron. It wants to pair that up with something to get a more stable configuration. So what this is going to do now is this will attack the bromine molecule. Okay, it will grab one of the electrons from this covalent bond to form CH3 with bromine, which will leave us with another bromine free radical here, which in turn can go on to react with another methane molecule, and so on and so on. So this is why this is described as a chain reaction, and these are the propagation steps. They're the steps through which the reaction keeps going. So during this propagation phase, we can see we've got 2 products that are being produced. Remember, we started off with methane and bromine, and we've moved down to this propagation phase, and now what we've got being produced here is hydrogen bromide. Let's put a rectangle around that, and bromomethane. So we've got hydrogen bromide and bromomethane, and we've got these free radicals hanging around, right there and there, in this kind of mixture of different substances. So this reaction will continue going, this propagation phase will continue going until these free radicals get completely used up. And so eventually we will come to what we call the termination phase or stage, where these free radicals react with each other and the reaction comes to an end. And there are 3 ways that can happen. So first of all, way 1, we could have bromine free radical reacting with another bromine free radical to form a bromine molecule. Those 2 unpaired electrons combine together to form a single covalent bond. Okay, so we're getting our bromine gas back again. The other possibility is that the bromine free radical combines with a methyl free radical. I'll write this as CH3 with this electron here to represent the unpaired electron to save me a bit of space. Okay, and that gives me bromoethane. And finally, the methyl free radicals can combine with each other. So you could get, and this time I'll do the structural formulas, right? CH3, that's the methyl free radical with this unpaired electron, reacting with another methyl free radical, and these two unpaired electrons combine together to form a single bond, forming ethane. Okay, so what we've actually got in this reaction are three possible products. One of them is hydrogen bromide, another is bromomethane, and another one is ethane. As a summary, the reaction between bromine and methane can result in the production of hydrogen bromide, bromomethane, and ethane.